All right, here we go. Buckle up, baby. It's going to get a little bit more difficult. Okay. So if I zoom in here, question number 4, it says, what's the probability of a 7-digit phone number generated using these digits? Comes out to be that exact number right there, 222 3357. Well, there's only one number, 222 3357. So up in the numerator, we're definitely going to have a 1. Okay, because there's only one number that's that number right there. So I want you to think about all probability is favorable over total possible. Total possible. So really our flow chart here, why do I have the 1 up there? Maybe I said that wrong. And probability is favorable over total possible. So in our situation, we got only one number. Our favorable is 1, right? So what I need to do is I need to figure out where in the flow chart does that guy go, right? So right down here, is the order important in a number? Absolutely, it's important, right? Like if I would have put the number 5 first, well, that would not be the same number, right? So the order is super important. Okay. So we come down here, and then here's the trick. Okay. We have some numbers in here that are repeated. 2, 2, 2. It happens 3 times. I'm looking for my move button here. So I'm going to move it over here to repetition. This is a repetition situation. So remember what I said up at the top. We're just trying to figure out the denominator right now. We know there's only one way to get this number. That's our favorable. So let me just reemphasize that. Our numerator is a 1. Our denominator, our total possible ways, is really what we're trying to figure out. So we're taking these numbers and we're going to permutate them. There's 7 numbers, right? So we're going to go 7 permutate 7. But there's some repeated ones. So when you have repeated ones, you got to divide by the number of times a number is repeated, factorial. So the 2, check, check, check. There are 3 2's. Okay. So what I'm going to put right down here is I'm going to put 3 factorial. And then how many 3's are there? Check, check. There's 2. You notice that there's 2 3's. So there's 2 of those guys. There's 2 3's. So I'm going to put 2 factorial right there. All right. Now, 7 permutates 7. We said that's the same as going 7 factorial all over 7 minus 7 factorial, which gave us a 0 in the denominator. Well, not 0 in the denominator, because it's 0 factorial in the denominator. And so when you have really 7 permutates 7, you don't really need to worry about the denominator. The denominator is coming out to be 1. The numerator is 7 factorial. So this stuff right here, okay, so we got 1 because there's only one way that we got that number. That is, there's only one number like that. And then down in the denominator, we have 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1 times 2 times 1. Now we're looking for things that'll simplify. So 2 goes into 2 one time. 2 goes into 4 2 times. 3 goes into 3 one time. So what do we have left? We've got 1 all over 7, 6, 5, 2. 7 times 6 times 5 times 2. Multiply those out, put it in a fraction, put it in for number 4. Okay. Thanks for watching problem number 4. If you want a little help on problem number 5, I'm going to do that one right now. Okay. So you're welcome to just put the video on pause, or you can, follow along with me and try this guy right here, number 5. Okay. So now we're given employees ID numbers, and the ID numbers are going to use 1 through 9. We're not going to use a 0 in their ID number, and there's only 5 digits. Does the order matter? Absolutely. You get a different number if you rearrange the order, right? So the order is a big deal. So let's follow our little flow chart. Order matters. So I'm going to be doing a permutation. Let's go down here. Are there any repeated numbers? Like in 1 through 9, do any of the numbers get repeated? No. That's like 1, 2, 3, 4, 5, 6, 7, 8, 9. There are no repeated numbers. So I'm going to move it over here to repetition. So in this situation, I'm not going to need to divide by the repeated, the number of repetitions factorial. What I am going to do is I'm going to put a 1 in my numerator again. Why a 1 in my numerator? Well, there's only one ID number that's exactly that ID number. Okay, so that's why the 1, the favorable is a 1. Down the denominator, here's what I'm going to do. I'm going to do, there's 9 digits, and I'm going to do 9 permutate 5, because there's 5 digits that we want to pull from these 9 over here. We want to know how many different ways. This would be impossible to draw a tree diagram for. So now we're going to follow that little formula that we had up here, and the formula looks like this: 9 factorial all over 9 minus 5 factorial. All right, now we need to simplify that. So maybe we don't even worry about the 1 until we finally put in our answer, okay? So I'm just going to focus on the denominator. So the denominator is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And it's all over 9 minus 5 would be 4, right? So I get 4 times 3 times 2 times 1. All of these are going to divide out with all of those. And really, we just need to go 9, 8, 7, 6, 5. Do that on Desmos. These guys, these factors are what's in the denominator. Let me finally write my answer right down here. A 1 is in the numerator. All of those guys are down in the denominator. 9, 8, 7, 6, 5. Do it on Desmos. See what you get. If I made a mistake, I apologize. We'll talk about it in class. Thanks for watching my